Good morning. In this particular video, we will see how to form, or rather how to determine risk and return of a portfolio of more than two securities. Although we will restrict ourselves to just three security case, but the same method could be applicable to more than three. That is n. If I have n number of securities, I can apply the same method to determine the portfolio risk and return using Markowitz approach. So at the bottom, I have shown the formula for determination of portfolio return and risk. It is the same formula which I have shared in last video. It is just that now the same formula is rearranged in matrix form. We already know, like, these are nothing but this is my weight matrix, that is weights given to each security. It is just mentioned in a row matrix form, that is just in one row. These are my returns from n number of securities represented in column matrix form. Likewise, for calculation of variance of my portfolio, again it is nothing but my weights assigned to each security in a row matrix form. This is my variance covariance matrix among the securities. Like, if I have n number of securities, there will be n variances plus covariance among each security, that is between each security. So this can be arranged in a variance covariance matrix form, that will be a square matrix of order n cross n. And then it is again my weights assigned to n number of securities, but now it is in column matrix form. Earlier it was in row matrix form, now it is just nothing but just transpose of that. So we'll see how to determine or how to use these matrix multiplication for determination of portfolio return and risk. So I will start with calculating returns for these securities using that same formula of PT plus 1 minus PT divided by PT into 100, because I am calculating in percentage form. By doing this, I have calculated the return of each of the security returns. Now I will determine the mean returns and variance of securities. Mean returns, I am using the same formula, that inbuilt function of Excel, that is average. Now I've selected my data. I've got mean return of HUL as 21%. Likewise for ICICI 7.45% and Infosys as 1.31%. These all were the closing prices of securities HUL, ICICI and Infosys. These were annual closing prices starting from 2011 to 2021, on which I am performing this. Now variance, again the same inbuilt formula of Excel. I determine the variance of securities. So I've got individual risk and return of securities. Now my objective is to determine the portfolio return and risk. For that, first I need to determine this variance covariance matrix. For that matter, I will follow I will first determine the excess return matrix. I will form excess return for each of the security per year over and above their mean return. That will be my objective. I will determine this. So each year's return minus mean return of security. Now I will freeze this cell by putting function F4. Likewise for them also. I'm doing this. Likewise for Infosys also. Now I will just drag this to get excess return from the means of each of the security. Now because it is being calculated using some formula, so I will just simply copy and paste the values of that so that when we will use that further, the values will not change. So I'm just copying and pasting same values. Okay, okay, because I have merged this, so it is not. So I will again do this, and then we'll copy and paste here only the values. It was not because of that actually. It was the destination cells were merged. Now I have got the values of that. Now, to determine the correlation or covariance between securities, what I need to do, I need to like formula for covariance is summation of Ri minus R average into Rj minus R average, Rj average in fact, divided by n minus 1. I'm using this formula for that, for calculation of covariances. So for that matter, I have to, because I am forming a variance covariance matrix, so the same matrix has to be multiplied with each other, but in transpose form. So I'm just copying this and putting it here. I'm again pasting this, but now I'm using paste special and just clicking on transpose. I've got the transposed matrix, right? This is my transpose of excess return matrix. Transpose of excess return matrix. Now I can multiply these two. That will be another step towards achieving that or reaching to the variance covariance matrix. So because I have three securities, multiplication of them will give me a 3 cross 3 matrix. So I have selected a 3 cross 3 matrix. Now I am using matrix multiplication formula, which is M mult. So transpose of my excess return matrix, comma, my excess return matrix. Now, instead of just putting enter for matrix multiplication, we always use Control, Shift, and Enter. I have got the multiplication of these two. I will write product of transpose and excess return matrix itself. Right. Now, next step is to determine the variance covariance matrix. I'm forming that variance covariance matrix here itself. because that I would be using many times. Variance, covariance matrix. It will be nothing but this divided by number of observation minus 1, that is number of returns I had minus 1. So do I will use this count function to determine how many returns I had. Okay, I had these many returns minus 1. That will be my first cell for variance covariance matrix. And how to determine which variance, what is the relationship between them? I'm just, because I'm aware of how that matrix multiplication had took place, so I can see these are the diagonal elements of this matrix which represent the variance of that particular security. Like this is the variance of HUL, and this we have already calculated. We can match it. Yes, variance of HUL is 410.1416. Likewise for ICSI 1424, and for Infosys 1549. So now we are done with variance covariance matrix. Now we can form our portfolios. So I'm putting down just weights because based on my weights, portfolio risk and return will change. So I'm just putting down this thing. Next will be my risk and a return of my portfolio. This is my portfolio. Let's say I'm just putting down some random numbers. The weight should be equal to 1. So for Infosys, I'm just putting down this plus this so that whatever weight I can put over here in HUL and ICSI, the weights in Infosys will adjust accordingly because I cannot put more than 100% of. Right now, my assumption is this. Let's say I am changing my weights like this over here, and here again let's say 0.05, 0.05, 0.1, okay, 0.15, 0.1, whatever. I'm just putting any random weights. I'm just putting random weights, anything. Let's say I have taken these random weights. Now, first I will calculate the return. It seems easy. So it is nothing but matrix multiplication of weights, put it on each of the security in, that is row matrix, into in column matrix the returns. I'm just taking and mult, that is matrix multiplication. I have selected the weights, comma. Second arrow, second array will be these mean returns, but this is mentioned in a row matrix form. I have to convert that into the column matrix. I will transpose that using inbuilt function transpose of Excel. Then I will select these array. And now again, because it is a matrix multiplication, I have to press Control Shift Enter, not just Enter. So I've got my returns. Okay. Why it is showing error? Because I have not freezed. I has to freeze these cells using function F4. So whenever you are done with your formula, always enter in matrix multiplication. Always press Control Shift Enter. Otherwise, you will get some error. Now I have got my returns. Now it's time to evaluate the risk. So again, it's weights only, but it's a matrix multiplication. So first array is my weights, then it will be a matrix multiplication of a product of two matrices. So again, I'm using that formula, matrix multiplication. In this, I'm selecting this variance covariance matrix, comma, again weight matrix, but in transposed form. So I'm using this transpose, again Control Shift Enter. I have got my risk. Why again values? Because again I have forgot to freeze my cells. Okay, so I have to freeze this. I have to freeze this. That's it. Again press Control Shift Enter and you will get the risk and return. Now I have to plot to check the characteristic of this curve. Again go to Insert, select Scatter Chart, and I have got the scatter plot between risk and return of my portfolio. Right. Now I want to introduce you with a concept in which we can determine the minimum risk portfolio. We can find the minimum risk portfolio. How we can do that? Just select any portfolio. Just my objective is to minimize this risk. For that, go to your data tab, go to this solver. If it is not showing over here, just go to your file and add in this. Now, my objective is, this is my objective cell. Objective is to have this as minimum. By changing which cells? By changing these cells and this two cells. Right? Third one depends on the input of first. Now, I want to okay, I will again my objective is to minimize this cell by changing this cell, comma, this cell, and I have certain constraints. Constraints are this should be less than or equal to 1. Again, the weight should be less than or rather should be greater than or equal to 0. Again, constraint for this, it should be less than or equal to 1 and it should be greater than or equal to 0. So I have put down all my constraints. Now I will go to solve this. I'm keeping this solver solution only. So I have got, like, if I put 68% weight in HUL, 12% weight in ICICI, and almost 20% weight in Infosys, at this level, my risk of my portfolio will be minimum. So this is how we can evaluate risk and return of these many different portfolio, we can have n number of portfolios, just depending upon the weights put on these three companies. So we can determine the risk and return of them, and this is the risk obtained by a portfolio which is having minimum risk. We have used solver to identify this. Okay, so in the next videos, we would be sharing some other concepts, some other workings. Bye.